Hello everyone and welcome to this video lecture. My name is Ram Kumar Sahu and I am from Department of AI ML Techrocrats Group Bhopal. In my today's topic, I want to discuss about introduction to data structure, array and linked list related to subject data structure. The content of today's lecture are introduction to data structure, classification of data structure, memory allocation, array and its types, operations on array and linked list and their types. Data structure. A data structure is a storage that is used to store and organize data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. A data structure organizes, processes, retrieves, and stores data, making it essential for nearly every program or software program. Classification of data structure. The data structure broadly classified in two categories, primitive and non-primitive. Primitive data structure, that means primitive data structure are the basic building block of data manipulation. These includes integer that represents whole values or whole number, character that stores single character, boolean that holds values true and true or false, float that contains the number with decimal point, pointer that is the address of other variable. Now, non-primitive data structure, they are generally categorized into way linear and non-linear. Linear data structures arrange the data in a sequential manner and it is classified into category, that is the static and dynamic. The static means the size and structure of static data structure are fixed, predetermined at compile time. Dynamic data structure, these data structure are more flexible and can grow and shrink runtime. The dynamic data structures are linked list, stack, and queue, and the static data structures are array. Nonlinear data structure. Nonlinear data structure that allow data to stored in a non-sequential manner, facilitating quick retrieval and linkage based on the relationship. The two types of nonlinear data structure that we are using, tree and graph. Now, going with memory allocation. In C++, memory allocation is a process by which computer program and services are assigned physical or virtual memory space. The memory allocation is done either before or at the time of program execution. There are two types of memory allocations. Compile time are also called static memory allocation. Runtime are dynamic memory allocation. Static memory allocation. Static memory allocation is allocated for declared variable by the compiler. The address can be found using the address of operator and can be assigned to a pointer. The memory is allocated during the compile time. Dynamic memory allocation done at the time of execution or runtime is known as dynamic memory allocation. There are two kind of functions that are used to allocate memory at the time of dynamic memory allocation in C++ that are calloc and malloc support allocating dynamic memory. In the dynamic memory allocation, a memory space is allocated by using each function when the values is written by functions and assigned to the variables. First data structure that we are using, that is the array. As we know, array is the non-primitive linear kind of strict data structure. An array is a collection of items of the same variable type that are stored at contiguous memory locations by a single name. It is one of the most popular and simple data structure used in programming. The types of arrays, there are two categories when we can categorize the array on the basis of size and on the basis of dimensions. On the basis of size, there are two kind of array, that is the fixed size array and dynamic size array. On the basis of dimensions, there are two types, that is the one dimensional and multi-dimensional. This picture shows the declaration and initialization of array. The array mainly contain info part, index, and the address. There are different data structures operations that are used on the array. Traversal in array, that means visiting each and every element of a array exactly once. Insertion, that means we insert new element into a existing array. It can be done at the beginning of the array, at the end of the array, and at any position of the array. Deletion can be also performed three ways: from the beginning of the array, beginning of the given position, and the first occurrence. All the occurrence and from end. Searching, that is the linear search and binary search. That means searching of an element from given array. Second one is the linked list. It is also a non-primitive linear kind of data structure. A linked list is a fundamental data structure in computer science. A linked list is a linear data structure composed of a sequence of nodes where each node contains data, that means information, and references are linked, that is a pointer to the next node in the sequence. It mainly allows efficient insertion and deletion operation as compared to the array data structure. Common operations in linked list. A linked list supports several operations: traversal, insertion, deletion, searching, updation, reversal, etc. Types of linked list. There are different variations or types of linked list, such as singly linked list, doubly linked list, circular linked list, singly circular linked list, doubly circular linked list, multi-level linked list, etc. Here represent the singly linked list, in which each node contain there are two parts. First part contain info field and second one the link field. Field contains information and link field contains address of next node. The advantage of singly linked list are dynamic size, no fixed limit. Like array, it can be shrink or expand as per the requirement. Efficient insertion and deletion at beginning, and we also have insertion at the middle efficient if we have reference or pointer to the node after which we need to insert. Can we implement complex data structure like stack, queue, and graph? Disadvantage: extra memory required for storing pointers, no direct or random access, case unfriendly. Doubly linked list. A doubly linked list is a more complex data structure than a singly linked list, but it offers several advantages. The main advantage of doubly linked list is that it allows for efficient traversal of the list in both the direction. Here we show a node that contains a data field and two pointers. Left pointer connect with left node and right pointer connect this node with next node. Advantage and disadvantage of doubly linked list. Advantage: bidirectional traversal, efficient deletion, insertion at both ends, easy to implement, navigation feature. And disadvantages are extra memory per node, because each node requires an additional pointer previous other than next, making DLL more memory consuming than singly linked list. More complex implementation. Both previous and next must be handled carefully during the insertion and deletion. which increase the chances of errors. Slow operation due to overhead, not cache friendly. Next linked list is circular linked list. A circular linked list is a data structure where the last node points back to the first node, forming a closed loop. Structure of a circular linked list: all nodes are connected in a circle, enabling continuous traversal without encountering null. Different from regular linked list, in a regular linked list, the last node point to null, but in a circular linked list, it point to the first node. What are the different uses of this? Ideal for tasks like scheduling, managing playlist, were smooth and repeated. Next linked list is circular singly linked list. In circular singly linked list, each node has just one pointer called the next pointer of the last node points back to the first node, and this result in forming a circle. In this type of linked list, we can only move through the list in one direction. Next one is a circular doubly linked list. Each node has two pointers, previous and next, similar to the doubly linked list. The previous pointer point to the previous node and next pointer point to the next node. Advantage of circular linked list: efficient traversal, no null pointer or reference variable, useful for repetitive tasks, insertion at beginning or and in taken time to be O of 1, uniform traversal, efficient memory utilization, etc. The disadvantage of circular linked list are complex implementation, infinite loop risk, harder to debug, deletion complexity, memory overhead. For doubly circular linked list, like not cache friendly. Okay, thank you.